Now we are taking three examples. The first differential equation is y double prime minus 6y prime minus 7y equals 0. Now, as you know, we use the ansatz or the test function y equals e to the mx is our solution. Then you know y prime will give you m e to the mx. Y double prime gives you m squared e to the mx, because you know the derivative of e to the mx is e to the mx, and then derivative of mx is just m multiplied with it, which is basically the chain rule. Now, using those values, in the first one you are getting m squared e to the mx minus 6 m e to the mx minus 7 e to the mx equals 0. And then if you divide both sides by e to the mx, because e to the mx is non-zero function, then you get m squared minus 6m minus 7 equals 0. And then find the factors from 7 so that their sum will be negative 6, which is negative 7 positive 1. So then the factors look like m minus 7 times m plus 1 equals 0. From the 0 property, now we see m equals 7 and m equals negative 1. These are our characteristic roots, which are real and distinct. So then we can write the solution as y1 equals c1 e to the negative positive 7x, and y2 equals c2 e to the negative 1x, which is just c2 e to the negative x. And then when you write the superposition of this one for number 1, the general solution y will be equals c1 e to the 7x plus c2 e to the negative x. And we are done for the first one. Now for number 2, we'll be using same function y equals e to the mx, and then y prime, y double prime are known. If you plug it in the equation number 2, you get m squared e to the mx minus 6 m e to the mx, and then plus 9 e to the mx equals 0. And you factor out e to the mx or divide each term by e to the mx, you end up with m squared minus 6m plus 9 equals 0. Now the trinomial factoring, you know that it is m minus 3 times m minus 3 equals 0. So that tells you m equals 3 comma 3. So in this case, characteristic roots are real and equal. So the solution for this one will be number 2. General solution I'm writing it direct, because you have m is 3, so you get c1 e to the 3x, and the next one also c2 e to the 3x. Since I have e to the 3x, e to the 3x same, so I need to multiply second one with x also to write the general solution. So now we'll take you to the third differential equation, where we have complex roots. So you get m squared e to the mx minus 6m e to the mx plus 13 e to the mx equals 0. So then the characteristic equation you are getting now, m squared minus 6m plus 13 equals 0. Now if you try to find the factor pairs from 13, you don't find any pair that will make negative 6 when you add them. So we are using the quadratic formula. So quadratic formula is telling you minus b, so b is negative 6. That gives you 6 here, plus or minus squared, minus 6 squared will make it 36, minus 4 times 1 times 13 gives you 52 over 2 times a is 1. So you are getting 6 plus or minus 4i over 2. That gives me 3 plus or minus 2i. So we got the characteristic equations and the roots. So now I will be writing the solution for 3, general solution. The general solution is straightforward. You will write y equals, so the real part is 3, you write e to the 3x. And then under the parenthesis now we'll be using 2, which is the coefficient. For I, you write c1 cosine 2x plus c2 sine 2x, and we are done. These are 3 different solutions. Thank you.